there in the equivalent DFA of the following NFA. So this is ABC are the states, E is final, 0 or 1, 0, 1. So this will accept 0 plus 1 whole star 0, 1, end with 0, 1. All combinations of zeros and ones end with 0, 1. So this will accept, we can have a DFA for this equivalent. So we can have total, we can have the states, 3 states, at a maximum we can have 2 power 3 states in the equivalent DFA, that is 8 states, that is a maximum. But minimum we can have 3 states. It is possible with minimum states. For 0 plus 1 whole star 0, 1, the DFA will be like this. We can consider like this, 0, 1. This is C. Before that we can have 1. We can have 0 here. We can have 0. We can have 1 here. So this is the DFA for accepting end with 0, 1 strings. So 3 states are sufficient. Option B is the right option here. And minus 42 base 10 in binary using 8-bit ones complement representation. So first of all you have to find out the value of 42 in binary. The value of 42 in binary is 101010. This is using only 6 bits, but you have to represent in 8 bits. So this value, this is a negative number. Negative number sign will be 1. So total including sign bit, it should be 8 bits. So we can represent like 0, 1, 0, 1, 0, 1, 0. This is the 8 bits representation. General sign followed by magnitude. This is a magnitude, 7-bit magnitude, 1-bit sign. So ones complement representation of magnitude only we will find out. So it will be 1, 0, 1, 0, 1, 0, 1. So total value will be 1, 1, 0, 1, again 0, 1, 0, 1. So this is equivalent to option B. B is right option.
If t of n is equal to 60 n by 3 plus n square into log n, then t of n is option A theta n log n, option B theta n square log n, and option C theta log n, option D none of these. We solve these kind of problems by using Master's theorem, and in Master's theorem there will be 3 cases. Here t of n will be compared with A into t of n by b plus f of n. So case 1 states that in case 1 we will check if f of n is order of n power log a to the base b minus epsilon. If this is satisfied, then t of n is theta of n power log a to the base b, where epsilon should be greater than 0. This is the first case. Case 2 is if first case is failed, then we'll go to second case. In second case, if f of n is theta of n power log a to the base b into log n power k, where k should be greater than or equal to 0. If this condition is satisfied, then t of n is theta of n power log a to the base b into log n power k plus 1. So this is the second case. If case 2 is not satisfied, then we'll go to case 3, and the condition for case 3 is if f of n is omega of n power log a to the base b plus epsilon, and a into f of n by b should be less than or equal to delta into f of n. If these two conditions are satisfied, then t of n is theta of f of n. So these are the 3 cases. Here in this problem, a is equal to 6, b is equal to 3, and f of n is n square into log n. And if we apply these three cases, the third case condition would be satisfied. And according to the third case of Master's theorem, your correct option is option B. T of n is theta of n square log n, theta of f of n, which is n square log n. DFS can be used to A. Test the connectivity of the graph. Option B. Find the spanning tree of a connected graph. Option C. Find a path from one vertex to another. Option D. All of these. We use DFS to find the spanning tree of a connected graph, and if it is a spanning tree, then there will be a path from one vertex to exactly one there will be exactly one path from one vertex to another vertex. And if it is a tree, if we get a single tree, then it will be a connected graph. So here we can use DFS to test the connectivity of the graph, find the spanning tree of a connected graph, and to find the path from one vertex to another vertex. So here correct option is all of these. Which of the following statements are true or not true with respect to the given grammar? Here in this question, a grammar is given and three statements are given. First statement is star is left associative. Second statement, this operator arrow power operator is right associative, and it has third statement, it has lower priority than star. So this is a question. Here if we consider if we see first statement, star is left associative. Here if we see the second production, here T gives T star F. So the production with respect to star operation is right recursive. This is left recursive. So we can say that star is left associative. And this operator, if you see this operator, here the production with respect to the given operator is right recursive. So we can say that this is right recursive. Here third statement is this arrow operator has lower priority than star. Here if we see the grammar, we can say that plus is having lower priority than this arrow operator. Why? Because this arrow operator is executed earlier than this plus operator. So we can say that here and also arrow operator is executed prior to star operator. So we can say that this arrow operator is having more precedence, more priority than these two plus and star operators. So statement S3 is wrong. Here the question is, here in this question we have to identify the statement which is false. So here S3 is false, which is option B.
Instruction move CL, BX DX plus 16 represents which of the following addressing modes? Option A, based relative, based indexed. C, indexed relative. D, register indirect. Actually here BX indicates base and DX indicates the index register. This 16 indicates the displacement register. Okay, displacement value. Normally in base index register, the effective address we are calculating by adding base register value plus index register value plus if there is any displacement, that displacement must be added. So here this base and index plus displacement must be added to identify the effective address. So this will come under based indexed addressing mode. So option B is the right option.